Hi, I'm Kazi from India. Today we'll continue with something logical thing. I'll give you a task. The task is to create a half wave rectifier. Okay, this is my task. So I'll do it using if and if action, that is if else loop, which we generally use in C. Every programming we use if and if else. So from the ports and subsystems, I'll take if this is the condition, if action. Okay, and what else I need some source, so I'll take it as sine wave as my source, and I need a scope. I'll take it, so I'll minimize it. I'll give this sine wave here. Okay, so you know what is half-wave rectifier is. We all know that. Only we'll get during the positive cycle. During the negative cycle we'll get 0. So this is if condition, like number of input ports is 1, not a problem. You can give your any condition according to, you can just change it to number 2, 3 and 4. You can give any number of inputs and change the condition according to your requirement. It's up to you. For the half-wave rectifier, I think this is the good condition. It's a suitable condition using u1 greater than 0, and apply. Okay, and you all know this amplitude is 1. Okay, and I'll connect this to if action. So this if action block will perform only when the input is greater than 0. Rest conditions it will be 0, it will not perform. So I'll connect it should have some inputs. I'll connect it to sine wave as an input, then I'll connect this to scope. Okay, I'll run it. You can see the output here. I'll just auto fit it. Yes, you can see this is during positive cycle, during negative cycle is 0, and again it's only till 10 cycles because we had specified 10 here. You can do any, you can do up to your own requirement. I'll change its axis to 2. Okay, and I'll also change the legend, click legend. Okay, now I want the input and output to display together with the legend. Okay, with the legend, this is my input. I will change its name as half wave. Okay, and this is sine wave, and I run it, fix it. You can see, you'll see a sine wave here and a half wave here, and you can see below 0, after this point you can see it's 0 here. This is half wave rectifier. Similarly, we can even design full wave rectifier. That's even interesting. I may require the same thing for full wave too, so I'll just copy and paste it just to save time, and just drag and drop it here somewhere. Okay, I'll copy this if action, place it here. So this will work only for positive cycle, and I want this action to work for negative cycle. So during else condition, when the input signal is less than 0, I'll connect to this action table. This action a module will perform. I'll give the same input. Okay, and you can see this will work for the negative cycle, this will work for the positive cycle. So I have to get the full wave rectifier. That should be like something like this, full complete it should be like complete wave. Okay, and for this I need two more modules. I'll go to sources, I'll take, sorry, not sources, I'll go to math operations, I'll take add, I'll go to this commonly used blocks, I'll take gain. Since the signal coming from this out 1 is a negative, so I have to make it positive. I'll just invert it, I'll write -1. Gain is something like it will just multiply with a constant, so it will be inverted, it will become a positive sine wave, positive wave, and I'll add both the half waves. This is like generating your full wave from two half waves. Okay, so I'll take it here and I will make three axes. Okay, this is for the full wave, and I'll change it to full wave. Okay, I'll take this somewhere here. Okay, this is full wave rectifier. Sample. Okay, I'll run it. Okay, and I run it. I'll fix it. This is the input signal, sine wave. This is your half wave rectifier. This is your full wave rectifier. We can have one more step in between this half wave and full wave. We will have another half wave that is during the negative cycle somewhere here, and somewhere here. We can add those two in and get a third signal, but that's not required. It's clear now. This is full and this is half wave. So in the next video we'll do something more interesting. Every coming video will be more interesting than the previous ones, because you will be aware of more and more tools, you will be aware of using more and more components on the tools, so it will be easier for you to learn, easier for you to explore. MATLAB is a tool where you can explore yourself. You don't have to go to any courses, or you don't have to take any kind of courses on MATLAB. You can learn self. We also have an option called help here, so help Simulink, it will take you to a new window. So anyway, we'll see the next video. Let's meet in the next conversation. Okay, till then,